Hello. In the last video, we covered how to make your own WebSocket server, how we use the WebSocket server to make a connection with the client, that is our front end, and how we were able to create a browser-based terminal. In this video, we'll be looking at how we can containerize our application using Docker and then use that containerized server to deploy it on an EC2 machine. Now, don't worry if you don't know much about Docker. I'll be covering Docker in this video. I'll be talking about the best practices about Docker, how to set it up on your machine, and also how to run it as a non-root user. Because we don't want our terminal to have all the privilege that a root user has when we are giving access of it through our front end. We'll be starting by Dockerizing our backend application. But before that, we should understand what Docker is and why we're using it in this case. So what is Docker? Docker is a way for you to containerize your application so that it can run on any platform. Now, what does that mean? Consider that you have made an application on your Windows PC and it requires certain dependencies. Now, if you're sharing that with your friend, then you will expect your friend to download all the dependencies, exact same version, and the whole shebang. And only then will he be able to run the project. But what if there's a better approach to this? What if I said that you could actually just create an image of your project, share that image with your friend, and then all that he needs to do is just run that image in a container and done. That's all that he needs to run your project. Well, that's exactly what Docker is. So there are mainly three parts that are there in Docker, which are Dockerfile, Docker image, and the container in which it runs. So Dockerfile contains the configuration to create the image. Now, what is an image? An image is an immutable snapshot of your project that has been created in a containerized manner. That is, it contains all the dependencies and the exact versions and also specifications of your OS in a single image. Now, this image is what runs in a container. Now, what you will be mostly doing is that you will be pushing your image on a hub, something similar to GitHub, which hosts your Docker images. The most famous one for this is Docker Hub. Docker Hub is just like very similar to GitHub, just that it's a container registry for your Docker images. That's it. So what Docker will help us do is that we won't have to worry about any dependencies or the versions that they're running or on even their OS. We can just create a single image, push it to the Docker Hub, and then pull that image from Docker Hub to our EC2 machine and just run that image. We don't have to install any other thing. The best way, in my opinion, to download Docker into your machine is simply to download the Docker desktop app. I have already installed it for Mac. You can go through the other OS and their instructions from the Docker documentation. After installing Docker, we'll look at what a Dockerfile is, because that is where our image, that is the instructions that will contain on creating our Docker image. We'll be creating a Docker image of our API project, which is the backend. Let's create a Docker file. When we start with a Docker file, the first thing that we need to provide it is a from. This from will be the base image. That is right, the base image of our Docker container, of our Docker image. Now, we can install the base image of Ubuntu, but then in that case, we'll have to install Node.js and NPM again. Rather, what we can do is we can directly install the Node base image, which is built on top of the Ubuntu image. Let's see how it looks like. Node. And since I'm currently on Node version 21.7.3, that's exactly what I'll be using. 21 point. And in this case, your IDE should probably be helping you. And if it's not, then you can go to the Docker site, Docker Hub, and look at the available versions that the Node team has released for you. Right now, I could see 21.7.3 in the supported tags, and that's why I've been. That's the image that I'm using. Now, after that, what we'll have to do is that we'll have to provide it a working directory. This will be the base directory of all our commands that will be running in the future. So over here, I want the work directory to be the root directory. That's it, where I am right now. Another thing that I'll want to do right now is that I'll have to copy the package.json before I install or even copy my images. Now what copy does is that it basically copies the file from wherever it is in the base to whatever path you provided. So I'm going to provide it dot, which means that I want package.json to be copied from the root to the root of my Docker image. Now I'll be running my commands. Now, since I have used pnpm, I'll have to first enable pnpm and then run pnpm install. Now, after I've copied over my package.json and run pnpm install, which will install all the dependencies, I'll now go ahead and copy over all my files. That is my project files, which will contain the Websocket server. But if you look closely, the problem with this is that this 11th line will also copy over the node modules and the dist folder. Now that is something that we don't want. So similar to git ignore, in Docker, we have a file called .docker ignore. Over here, we need to provide the directories that we want to be excluded. So here I'll be providing node modules and the dist. But I don't want these to be included in my Docker image. Great. Now the reason for us to copy our files after we have installed everything is that Docker has a very smart caching mechanism, which means that every time you build an image, it uses its previous cache. Now what this enables you to do is that if none of your dependencies are ever changing, then you don't need to install those dependencies again ever. You just need to copy the latest code and you're good to go. Then we'll expose the port that our project is running on, which is 5001, because we need to understand that this will be a container, which is very similar to probably a virtual machine. Now we need to expose it explicitly that this port 5001 can be accessed from the outside machines, that is from our AWS EC2 machine or any other machine where the Docker image is running. Now finally, we'll be running the command pnpm start, which will run the start script of our package.json, which will in turn start the WebSocket server. Now note that the CMD is very similar to run. It's the only difference is that in run, a new shell is started and the command is passed to it. In CMD, nothing like that happens, but it directly runs this command. That's about the Dockerfile. Now let's see how we can use this Dockerfile to create a Docker image. So to create the Docker image, we'll first have to cd to the path where our Dockerfile is, which in this case is apps and API. Dockerfile is there. To build the Docker image from the Dockerfile, we'll be needing to run docker build command. And this build command needs the path of the Docker file that we have. So here what we can do is a docker build dot. And now this will go ahead and create our Docker image. And of course, I forgot to start Docker, and that's why I'm getting this error. Once Docker has started, then we can go ahead and run this command again. Docker's up. Once your Docker image has been built, you can run the Docker image by using docker run and provide the Docker image ID. And just like that, our image is running. Let's check this via Postman. And we are connected. That's great. Now the way you can tag your, name your Docker images is by providing the -t, that is the tag argument inside your CLI. So it will be something like docker build -t, provide the name. Now the name should be something that is based on your username on Docker Hub. So after you create your name in Docker Hub, you can use that as the root and then provide a slash and provide the name of the Docker image that you want. So over here, what I'll do is, since I've already created it, this is my Docker Hub ID, and I'll be providing it a name such as browser terminal, and I'll also be providing it the tag, the version number that is, which is 1.0. And now finally, we provide the Docker file path, which is dot in this case, because it's directly in this folder itself. Now what this will help us do is that we can use Docker run, and we can provide this name. That's how we are able to run the Docker image without actually having to copy the ID. Over here, we have more control over the name, as well as we can decide what to call it and how to share it with others. Now that our Docker image has been correctly named and built as well, we'll go ahead and push this to our Docker Hub. Now, since I've already configured Docker Hub, I've already created an account on Docker Hub, and I've already given my terminal the authorization to push to my Docker Hub. I'll simply go ahead and Docker push and the name of my Docker image. What this will do is that it will go ahead and prepare all the images and push it to my Docker Hub. Great, this has been pushed. Let's check it out. Docker Hub. BT. And this has already been pushed. And I can pull it using this command. Now, where will we be pulling it and what will be the use of this? We'll check out in the EC2 machine. But before that, we need to know how to launch an instance on EC2 and how to SSH into our EC2 machine using our local terminal. After logging into your AWS console, this is the home page that you'll be presented with. Now, since we want to deploy an EC2 machine, we'll visit the EC2 instance homepage, and we want to launch an instance over here. Right? Now, the type of instance that we want to launch will be of an Ubuntu type, because Ubuntu is the most widely used Linux distribution that is out there, and that's what we'll be using over here. It's very simplistic, and it presents us with a very clean terminal interface. We'll want for this use case, you can probably choose whatever free tier is available to you. I'll be using a T2 micro system over here with the lowest configuration. And yeah, this would be required if you are trying to SSH from your machine to the AWS machine itself, which we'll be doing. So it's important to create the new key pair and download it into your PC. BT for browser terminal. Now that our instance is up and running, we'll connect to it. To connect to it, there are multiple options. The one that we'll be using in this case is by SSHing into our AWS machine using our own local terminal. So this is how it's supposed to be done. We'll just copy it and open up our terminal. Now the first time you run this, it will give you this warning that it's trying to permanently add this host into the known host list. And that's all right, because this is an unknown host for our machine, and it verifies it, and then now it has been added to it. Now if we try to SSH into our machine, we will be able to do so. Now please note that I have saved the bt.pem, which is the key pair that is required, in my downloads folder, and I am currently in my downloads folder, and that is the reason I'm able to SSH directly using this single command. Now this is a different warning. Now what is the thing? That permissions for 0664 for BTPEM are too open, which means that other users on my machine can have access to BTPEM. So it's basically saying that I should remove the permissions of BTPEM and make it very restricted. I need to run this command, which will take away a lot of permissions and convert it into a 400. Now what 400 is a little out of scope of this video. So now the permissions of bt.pem, which is the key pair, has been changed. And now if I try to SSH it, now if I try to SSH into the machine, I will be able to do so. And I'm into my machine. Perfect. Now that I'm inside my EC2 machine, I'll go ahead and pull my Docker image. But I get that Docker is not installed inside my Linux machine. So how can I install it? So this is the command to install Docker inside an Ubuntu machine. I'll go ahead and copy it. Now once I've installed Docker using the install inside Ubuntu instructions, I'll go ahead and pull my Docker image. Now, after my Docker image has been pulled from the Docker hub, I'll go ahead and run this using the same command docker run inside my Ubuntu machine. Docker run and my Docker image name. Now over here I'm getting an error which is saying that the requested image's platform does not match the detected host platform. So how can we fix that? Well, to fix this, what we need is a way to build our Docker image in the same platform that our Linux machine is currently on. Now, this is the command that we'll be using to build our Docker image in a Linux AMD 64 machine, for a Linux AMD 64 machine. As you can see over here, this will ensure that our Docker image runs in every Linux AMD 64 machine. Of course, I'll have to cd into my API file before that, API folder before that. Once this has been built, I'll go ahead and push this using the same docker push command that we saw before. Docker push and the name of my image. And please note that the version of my image has been updated to 1.1 now. That's the image I'll be pushing. I'll pull the latest image from the Docker hub, which is 1.1. So it'll go ahead and pull it, and then it'll go ahead and run it. So Docker run will look for it locally. Since it didn't find it locally, it went to my Docker hub and checked if I have 1.1. Now, since I did have a 1.1 of my image, it installed it, it pulled it, and now it's running it. It's going to run it. And just like that, my Docker image is running perfectly. Now that our WebSocket server is up and running on our EC2 machine, we need a way for us to reach this EC2 server. We need a way for us to reach this EC2 server to access this WebSocket server. So let's see how that is done. Now, something that you need to know before that is Nginx. Now, Nginx is a way for you to handle reverse proxies on your server, which means that whenever you receive a request in your server, you're receiving a request in your server, it won't directly go to your server. Rather, it will reach your Nginx proxy, which is inside your server itself, Nginx proxy. And this Nginx proxy will go through this request and then redirect it to the appropriate server. That is, over here, we'll configure this Nginx configuration in such a way that any request that comes to us, we'll be redirecting it to localhost 5001. We'll start by installing Nginx into our EC2 server. Now, where the Nginx configuration is stored is by default in the path etc/nginx. Let's check it out. How is it looking? So this is what it contains right now. Now, nginx.conf is the file that contains the configuration of our Nginx reverse proxy. Let's see what it contains. All right. Now, I wouldn't recommend you to spend too much time understanding what this is and what's going on over here. Rather, let's understand, because we won't be changing this configuration file at all. We'll be changing the default configuration file that is inside the sites available folder. So the sites available folder contains a default file called default, and that is the one that we will be changing. Yes, this is the file that we will be changing. So over here, what we want is that we want a way to proxy pass, that is reverse proxy a request that is coming to the server, to our localhost 5001, where our WebSocket server is running. So over here at the location /, that is all the requests that are starting with /, we want the request to be proxied to the HTTP localhost 5001. That's what we'll be doing with the proxy pass key. Now, another thing to keep in mind is that whenever you update your Nginx config, you should always reload your Nginx so that your latest changes are transferred over. Now that our Nginx config has reloaded, we'll be checking if we can access our server from Postman. Now, to access anything from Postman, you need its endpoint. To get the endpoint, just head over to your instance's settings. And over here, you'll be able to find its public DNS. This is the DNS that you can use to hit your server. Now, when you hit your server, you'll notice that the request is not resolving. Well, the reason for this is that by default, all the ports to your instance are closed. So we need to expose certain ports on your machine to the public. Now, how will we do that? Head over to your AWS console and add a new security group. Now, this security group can be named anything. I'll be going for server, node server, and description. Just I'll leave it for now. And over here, this is the inbound rules of what are very important right now. So we'll be adding custom inbound rules for every HTTP request, and be saying that anywhere IPv4 6 is allowed. That is, any incoming source is allowed over here. Similarly, we'll be adding it for IPv6 as well. Now, as you notice, HTTP is running on port 80, which means that any HTTP request that comes to your server is by default going to go through port 80. And if you remember in your Nginx config file, we were listening on server on the port 80 for any requests that are coming through, and then routing those requests to the localhost 5001, which is running our WebSocket server. Similarly, we'll be allowing HTTPS requests as well. And if you notice, HTTPS requests always go through route 443, the port 443. And similarly, we'll be adding it for IPv6 and IPv4 as well. Now, another inbound rule that we should add over here is for SSH. That is, when we were SSHing into our machine. So over here, I've given SSH, and over here, it'll be any IPv4 and any IPv6. Technically, it should only be your IP and your IP only. But for the sake of simplicity, let's go for any. Save. Now, once your security group has been created, you can go to the instances, select your instance, and change its security group to the one that we created just now. Node server. Save. Now, if you go to Postman and you send in the request, you'll get something else. Bad gateway. Nginx error. So which means that the request is resolving now, which means the port 80 is exposed to the public. That means we can access the port 80 from anywhere in the world. But why are we getting this error? Well, this error has to do something with the way that we are running our Docker. Now, the problem with the Docker command that we were running, let's first run Docker PS to list down all the Docker containers that are running right now. So as you see, there's only one Docker container running right now, and it's running on port 5001. But the problem is that this is running inside the Docker. That is, the Docker is exposing the port 5001, but it is not mapped to our EC2 server's 5001 port. So how can we map the port 5001 from the Docker to our local host inside our EC2 machine? Let's see. First, we'll be killing this instance. First, we'll be killing this container. After that's done, we'll be running it again. But this time, instead of simply running it, we'll pass another parameter called P. And over here, we'll expose 5001 on port 5001, which means the port 5001 of the Docker should be forwarding all the requests to the port 5001 of our local host. And now we'll be running it. Now, if you see our Postman, let's see what's going on. Cannot get, which means the server is running right now. And if you remember, I had a few test routes over here, namely status. So let's check status. And great, our server is running. Let's also try running our WebSocket server, connect. The reason that we could not connect to this WebSocket server is because we did not allow it to upgrade to a WebSocket connection. Now, how do I know that? Well, because in our reverse proxy, we never did actually pass through any upgrade connection policies, right? So in our Nginx config, a thing that we did not add over here was the redirect and upgrade policies. So these are the rules that we'll be adding over here. That is, we have switched off any redirection that was going to happen. And the most important things over here are the upgrade and the connection upgrade. Now these two are used whenever we want to upgrade our normal HTTP connection to something else. Let's save this and reload our Nginx config and then try out our WebSocket. Now that it's reloaded, we'll be opening Postman and trying out the connection again. And this time we were able to connect to the WebSocket connection. And just like that, everything's working out. So if we copy this and go over and head over to our project, and instead of connecting to the normal localhost version of the WebSocket server, we'll be connecting to the EC2 instance. Okay, now that we are connecting to the EC2 WebSocket server, let's reload this page and let's see. Okay, as you see, we are connecting to the WebSocket that is on the EC2 machine and not any local host. And this is connected to the root of the Docker component of the Docker image that we have that we are running inside a container. And that's it. The terminal is working. But there are two improvements that we could make that would drastically improve the security of this terminal and this WebSocket connection. So right now this WebSocket connection is not a secure WebSocket connection. The way that we make this a secure WebSocket connection is by providing it a proper SSL certification. Now you can either perform SSL verification through some third parties like Google or Amazon domains, or you can also do it by signing it yourself. So what we'll be using for this is something known as certbot. Now let's see what certbot is all about. So when you land on the certbot page, you'll be presented with the where is it running and what's the system. So we are on Ubuntu 20 and we are running Nginx. Now we need an HTTP website that is online and open on port 80. Now we pass all these criteria, so we can go ahead and just follow whatever they're saying. So we need to install snapd. Let's see how to install snapd. Snapd is already pre-installed in Ubuntu, so we don't need to install it again. Let's go ahead and remove any certbot configurations that might be there by chance on our SSH server, on our EC2 server. Let's install certbot now. Now that certbot is installed, we can move on to the next step. I'm simply following whatever certbot has given it in its documentation. The most important step is to configure the certbot with Nginx. That's what this command will do. Over here, I'll have to give it my domain name. For the domain name, I'll simply be heading over to my EC2 instance and copying the DNS name, which is this. And that's the DNS name that I want. Now, since I don't own the Amazon AWS domain, I need to buy a domain and then be able to configure it. So I've already bought a domain. Let's try it out. So I own the domain kale.pro and I'll be heading over to the DNS, advanced DNS, and I'll be marking my domain name as this public IPv4 address, which means I'll be adding an A record with a host name of WebSocket 1 and I'll provide the IP address of my machine. Now once this is done, I'll now be able to use ws.1.kale.pro to redirect any requests to this IP address, which is my EC2 server. Now let's try running it with our own domain name. And just like that, ws1.kale.pro, the domain name that I own, will now point to my EC2 instance that is running the WebSocket server. Let's see. I'll be replacing this with my new verified WebSocket server link, which is ws1.kale.pro. Now let's see. And this is working. My WebSocket is now 100% secured. And as you can see, this is going through a secure WebSocket rather than just a WebSocket. And that was all that is required to set up a secure WebSocket server on an EC2 instance. Now, another security measure that we can take over here is that we don't want this terminal to be running on the root. Rather, we would prefer if another user that we create that has less privileges runs this project, runs this terminal. Now, how do we do that using Docker? Right now, if you see a Docker file, we are running this as the root. We are not configuring any user or any such thing right now. Now, the way for you to add a user into your Docker container is by running run user add, and we'll provided a few parameters over here, CLI parameters, namely M and S. And then we'll be giving it bin bash, and then the name of the user will be API. Now, bin bash is the default shell of the user. Now, what MS stands for is that the M creates a home for the API at -home-API. So there'll be a home at -home-API. This will be the home of the user. And what S does is that it creates a shell for the user, the configuration of the shell for the user, which is bin bash over here. That is, the user will be using bash as his default terminal. Now, what we'll be doing over here is that we'll be moving the work directory from dot to home-API, home/API, because that is where the user will be logged into. Similarly, we won't be copying the package JSON to the root. Rather, we'll be copying it to home API. And finally, before exposing the port, we'll mark this as user API. Now let's see what this does. We'll go ahead and rerun our Docker build. Once the build is complete, we'll be pushing it to the Docker hub. Once the Docker image has been pushed to the Docker hub, we'll be killing the process that is running on our EC2 machine currently. And then we'll be taking the latest pull of 1.2. And just running Docker run 1.2 will first pull it from the Docker hub and then run it again. But you know the mistake that I did over here? I did not expose the port of my Docker to my local machine. So what I need to do over here is that I'll need to cancel this Docker command, and then I'll need to expose the port 5001 to my localhost 5001. And this is the right command over here. Now, once this is done, we can head over to our localhost 3000 and check how this EC2 machine is looking now. And just like that, you're not anymore the root user, but you're rather the API user. And that was the video. We successfully deployed a Websocket server on an EC2 instance, and we made it completely secure using certbot. We used Nginx for reverse proxying all the requests that are coming through on our EC2 instance. And yeah, all in all, it was really fun. I'll see you in the next one.